Okay, hi Addie. Welcome to today's math lesson. I'm super excited about today's lesson because today is a really nice review of everything that we've done so far, and then there's this really fun extra concept at the end. So hang in there. It's a little bit of a long, if you look through the book and you're following along, you'll see that it's lots and lots of pages, but I'm going to condense it because I know that you know a lot of it already. First of all, let's read this together. My brother took going to jail really badly. He refused food, drinks, he spat and swore at anyone who came near him and started throwing things everywhere. After that, we never played Monopoly again. So he didn't really go to jail. He just went to jail in Monopoly. But that is it can be a little bit of a disturbing game. All right, let's jump right in. The first thing that we're going to do is it goes over in the lesson that a number is just an idea. So a number is an idea. What does that mean? Well, if you look at these things, they all have the quality of threeness. T-H-R-E-E-N-E-S-S. So this brings to mind the number 3. And of course we use numerals or symbols to represent those ideas. Okay, that's all they want you to know, that a number is an idea. And the number 3 can be represented by any of these things. This is obviously a Roman numeral. The number 3, it can be a fraction, 30 over 10, 33 over 11. And any of these things, these are all the value of 3. All right. Let's just jump right into the next because I think that we can move on from there. The next point is that we have a decimal system, and the decimal system has 10 symbols to it, and you would think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, but it's actually they count 0 as one of the symbols. So of course when you put 0 and 1 together, then you get the number 10. And they also point out that we have a base 10 system. That means like we count by tens, 10, 20, 30, 40, 50, up to 100. And there are multiples of 10 when you go from 10 to 100 to 1,000, things like that. Why do we have a base 10 system? Because some people think it would be better to have like a base 12 system. And there's some advantages to that. And we might talk about that at some point because it's actually super interesting. I read this really awesome math book that went over that. But the reason we probably have a base 10 system is because we have 10 fingers. And so it makes it kind of easier to count to the number 10 and keep track of tens. Isn't that interesting? If we had maybe 12 fingers, we might have a base 12 system. Kind of cool. All right, then it goes over counting numbers. So counting numbers doesn't start with 0 like the other one. It starts with a number 1 because it's natural to start with a number 1. And it's all the whole numbers that we count, right? So it doesn't include the number 3/4 or 0.75 because we don't tend to count those. We just count 1, 2, 3, 4, 5, 6, etc. All right, so those are natural numbers. Okay, real numbers. So this reminded me of Pinocchio. I want to be a real boy. So what is the definition of sort of a real number? A real number, the way that it's defined is that if you can use the number to describe a physical distance that's greater than 0, then it's a real number. So anything that can be used to describe a distance. And that's another reason why I put Pinocchio here, because he wants to be a real boy, so that reminded me of real numbers. But can you measure the length of his nose and describe it with a number? If you can, then that's a real number. Okay, so let me show you some examples and then I think you'll get it. Okay, so these are all real numbers. So 3/4, the number 3/4. Could you describe his nose by the number 3? Yeah, you could. You could say it's 3/4 of an inch long or 3/4 of a foot, something like that. So that counts. What if his nose would be tiny? It might be this number, 0.000163. Or it could be 0.00163 and then the unit is miles. So it might not be tiny. It just might have a humongo unit on there, right? But yes, you could use that number to describe a distance. 363, you could obviously say like 363 feet or inches or something. 3 3/8, yeah, we do that all the time when we're measuring, things around the house or bolts or things like that. It might be 3 3/8 of an inch. 46, obviously, yes. Even a fraction, yeah, you could count that as a distance. It might be 11/7 of a centimeter or something. And then so all of these are real numbers. What about the number 0? They point out that 0 is not a positive number. It's not exactly a negative number either. 0 is a super interesting number. They had a whole chapter on 0 in that math book that I told you about. Anyway, but you could use the number 0 to describe a distance because it could be like 0 miles. Right now, you are 0 miles away from your bed, I bet, because I bet you're listening to this while you're in bed. Anyway, yeah, so that can be used to describe a distance. So it is a real number. We do consider it a real number, but it's not exactly a positive number. Negative numbers are interesting too, and I put some pictures of sheep here because the chapter kind of talks about how ancient people didn't have a concept of negative numbers. For example, you can't own -10 sheep. So they understood that you could own 4 sheep, like in this picture, or one cute sheep here. Look how cute that picture is of that sheep. It's adorable. Oh my goodness, and so silly. But you couldn't really own negative sheep, so they didn't really, if you would have traveled back in time and said something like that to them, they'd be like, that doesn't make any sense. But you can own -5 sheep because what if you owe your neighbor 5 sheep for some reason, right? You're in debt or something like that. So we do have a concept of a negative number now, and we understand that, but it's kind of interesting how that came about. Also, just a little reminder, if you write -7, it's negative on the number line to the left of 0. This is +7. This, if it has no sign, like no positive or negative in front of it, then we assume that it's positive. So anytime you see a number like that, from here on out in the book, you're going to assume that it's a positive number. All right, let's jump into number lines. There's just a few little vocabulary words that you need to remember with number lines. For example, the number 0 here is usually the origin. It's called the origin. So just pretend that this 0 is an O and it stands for origin. And then anything to the right of 0 is positive. It's a positive number, even if it's just barely to the right, like it might be 0.0001 or something. That is still a positive number. Anything to the left of 0 is negative. And then you can use a number line to do math problems, like +2 would be 2 in that direction, 2 minus 3, then you would go 1, 2, 3, and you would land at the answer, something like that, right? When you put a point on a number line, that means that you have graphed the number. So if you're ever asked to graph a number, that's what that means. And once you have a point there, that is called a coordinate. So you have a coordinate for that number. Okay, cool. I think that you get this. One more tiny little thing. You already know this. Greater than is to the right. So if you're asked, what is the greater number when you're talking about like -4 or -2, sometimes that can be confusing as far as which number is more positive, greater, or, like if you're using this symbol, where do you put the -4 and the -2? So the -2, even though it's a negative number, is to the right of -4, so that would be considered the greater number. So it would be, I did that backwards. -2 is greater than -4. That's because this greater than sign is going to, imagine it like an alligator mouth, and it is going to be eating the bigger number. And the bigger number is -2, even though they're both negative. That's confusing. Okay, let's move on to, opposite numbers. This is just a review of opposites. If you have a +2, the opposite of that is -2. The opposite of -1 is +1. Easy. So if you add them together, they're going to equal 0. Those are opposite numbers. All right. We are on fire. I knew we were going to be on fire at this point in the lesson because we are moving along so quickly. The hard thing about this lesson is that they expect you to know this information in here from here on out in the book. So even though I say it quickly and I only say it once, you're expected to know it and to remember it, and they're going to ask you questions about it. But I think you'll get it when they start asking you questions. I mean, you get math when you do a lot of math homework. That's how you get it, honestly. So you'll understand it. So don't worry that you have to memorize everything that I say, even though you do have to know it. Let's go over multiplying and dividing fractions. You've done this before, but just a quick review. When you are multiplying fractions, then it's super easy. There's only 2 steps involved. Step number 1 is you multiply the numerator. Step number 2 is you multiply the denominator. If you're following along, I'm on page 17, like partway through the page. So let's just go through and do this problem. So if we're multiplying 4 over 3 times 7 over 5, then what we're going to do is multiply the numerators. So 4 times 7, and we get 28. And then you multiply the denominators, 3 times 5, and you get 15. And then if you're one of your friends that's not so smart as you might think that you are completely done with this problem, but you're not completely done because you can simplify this. And you can change it to a mixed number. So 15 goes into 28 one time, and then there's going to be 13 left over. So you do 13 over 15 because the denominator stays the same. You don't have to change it to a mixed number every time. You can leave it as an improper fraction like this, but anyway, that would be how you do it. Okay, step B. The next part of this is how do we divide fractions? So this is another review on how to divide fractions. I think you know how to do this, but there are 2 steps involved. Step number 1 is you invert the divisor. That means the second fraction that you come across, the one that is the divisor. And do you remember how we did this? The dividend goes here, kind of like in the den of the house. The divisor goes on the outside because the guy was wearing the visor cap, remember? And then the quotient goes on top, and that's the terminology for division. So the second one here is actually the divisor. So the first step is we invert it, meaning we turn it upside down. And then the second step is we multiply straight across. So if you have a problem like this, which is 4/3 divided by 15 over 8, this is a super easy problem. I actually love doing this. It's kind of fun and satisfying. So all you do is you invert that second one, and then you just multiply straight across. Isn't that cool? You just turn division into multiplication, which is way easier. So let's do it. 4 times 8 is going to be 32. That's the numerator. And then on the bottom, we have 3 times 15. 3 times 15 is 45. And I don't think that you can simplify this anymore, so that is going to be the answer. Okay, if that was something that I love doing, which it was, this is my absolute favorite. So it has my stamp of approval for favorite, because can you cancel? Now, you know I don't like cancel culture, but I am so excited for this, as excited as Kermit the Frog, because I love canceling. It makes your life way easier when you're doing math, and it's super satisfying and fun. So the thing about canceling, and I think that you probably remember how to do this, but if something is the same on the top and on the bottom, you can cancel it out. So if this were a 3 and this is a 3, then you could just cancel it out and they kind of turn into ones when you do that. But if 3 goes into 30, you can still do a cancellation because you can keep the ratio the same. So 3 goes into 30 10 times. So because 3 times, this is not the same problem that is in the book. I just noticed that this should be a 9. Now it's the same as the problem you have in the book. So this is the problem on page 17. It's labeled C. So it's about halfway down. 7 over 3 times 30 over 9. That's the original problem. I was so excited to cancel, I made that a 10. All right, so what we're going to do is we're going to cancel. So we're going to cancel out the 3 because 3 goes into 30 10 times. So it's like this becomes a 10 and this becomes a 1. Because 30 over 3 is the same as 10 over 1. And so you can just cancel it right away. And when you cancel it, that makes your math problem easier because then you don't have to do 7 times 30. You can just do 7 times 10. So 7 times 10 is 70. 1 times 9 is 9. And boom, you're done. 70 over 9. But you can simplify that because the top number is bigger. And so 9 goes into 70 7 times, 9 times 7 is 63. So there's 7 left over. And then you keep the denominator the same. So 70 over 9 is the same as 7 and 7/9. That was so fun that I want to do another one. Okay, so this is a 3-part multiplication problem. So they want us to multiply all of these fractions together. That's a little hard to do because you would have to do 3 times 5 times 21. And that's a lot of multiplying. So again, make your life easier. Let's just cancel. There's a 5 on the top, a 5 on the bottom, so I can just make those 1s. Super easy, right? Okay, what else can we cancel out? Well, there's a 3 and there's a 6. 3 goes into 6 twice. 3 times 2 is 6, right? So if we change this to a 1, we can change this to a 2. Because, why do we do that? Because this is like 2 3s, right? Okay, so now this is super easy to multiply because we're doing 1 times 21, and we get 21 on top. What do we get on the bottom? 1 times 2 times 23, so we're just doubling 23, so it's 46. Haha, yay, that was fun. See how fun that was? I know, so fun. Okay, what about mixed numbers? You can change mixed numbers to improper fractions, and then you multiply or divide. So if they give you a problem like this, this is hard to multiply the way it's written like this. So what we would do is we would turn these into improper fractions first, and then we proceed. Okay, so let me do this example for you. So if we have 2.5 times 5 1/3. Do you remember how to turn mixed numbers into improper fractions? What you do is you do 2 times 2 and then add that number on top. Okay, so 2 times 2 is 4 plus 1 is going to be 5, and then you keep the denominator the same, so it's 5 over 2. So I'm going to erase all of this and put 5 over 2. Okay, let's do the same thing here. So we do 3 times, I kind of think of it as like a clockwise direction. You start at the bottom and you do like this clockwise direction. And you multiply and then you add. Okay, so 3 times 5 is 15, plus 1 is 16, so it's 16 over 3. So I'm going to change this to 16 over 3. Now our problem has turned into 5 over 2 times 16 over 3. Now this looks a little tricky still because of the math, but we can simplify again. So we can cancel out this 2 and the 16, right? So if I change this to a 1, I can change that to an 8. Now it's super easy because I can do 5 times 8, which is 40. And on the bottom, 1 times 3, which is 3. Yay! Oh, you can also change this to a mixed number because the top number is bigger. So typically we change that to a mixed number. So how many times does 3 go into 40? Turns out it goes into 40 13 times with 1 left over. So 13 times 3 is going to be 39, right? So then there's 1 left over, and keep the denominator the same. So 13 1/3. Okay, we are so smart. We used our brains on that one. Let's do another one. 12 1/3 divided by 2 1/6. So they're being tricky here because they gave us two mixed numbers, and look at this, they want us to divide. It's not multiplying, so we have to be careful. Don't let them trick you on stuff like this, those test makers. So again, clockwise direction, let's turn this into an into an improper fraction. So we're going to do 3 times 12, which is 36, add 1, and that is 37. So it's going to be 37 over 3. And then this one, we're going to do 6 times 2 plus 1. So that 6 times 2 is 12, plus 1 is 13 over 6. Alrighty. Now we are dividing. So don't let them trick you again, because when you divide, you have to turn this second one upside down. Okay, so if we just change the spots of that, then we can turn this into multiplication, and it's easy. Now, can we cancel anything? Oh yeah, oh yeah. The 3 and the 6 cancel, and you can make that a 1 and a 2. So that's a lot easier. 37 times 2 is going to be 74. And then on the bottom, 13 times 1 is 13. This should be simplified because the top number is bigger. And so how many times does 13 go into 74? Turns out it goes in there 5 times, and there's going to be 9 left over. 9 over 13. Bam! Easy. All right. Let's do one more. And you're like, again? Seriously? You want me to do this again? Yeah, we do, because it's so much fun. Okay, what did they give us here? This is the next problem, and it looks like this. You know what? This is like fractions over fractions, but all they're saying when they write something like this is that they want you to divide. So it's actually the same as this. So that's not a big deal. Not a big deal. We do what we always do. Let's turn it into improper fractions. So let's start with this one. We're going to do 3 times 3, which is 9, plus 1 is 10. So this is going to be 10 over 3. Let's change the next one into an improper fraction. 5 times 2 is 10, plus 1 is 11. 11 over 5. Okay. Now, don't forget, we're dividing, so we have to invert that second fraction. So invert that divisor. So let's change this. Okay. And then once I've done that, now I can make it a multiplication problem. Can we cancel anything out? Anything the same on the top and bottom? I don't think so, but this is easy enough math for us to do anyway. So it's going to be 10 times 5 is 50. On the bottom, 3 times 11 is 33. And we can simplify that because that's an improper fraction. So 33 goes into 50 just one time, right? And then there's going to be 17 left over. So it's 17 over 33. Bam! We got this, Addie. We're getting there. All right, let's go over the next topic is symbols of equality and inequality. I know. Hang in there. This is long, but you can do it. You can. Yes. Okay. All that means is these two things are equal to each other, so you put an equal sign. If anything is not equal, like 5 plus 2 obviously is not equal to 11, so you put this sign. This means not equal to, an equal sign with a slash across it. Okay, that's all they want you to know there. Now, basic operations, and I know you're struggling now. If you need to take a break, but don't sass me. Let's keep going. The basic operations are addition, subtraction, multiplication, and division. So let's do some review of those things. Addition. All they want you to know for this review is that each of these numbers, when you're doing an addition problem, is called an addend. Remember that? The answer when you do an addition problem is called a sum. You don't want to murder me for reals? No, you don't. Let's keep going. All right, so this is an addend, this is a sum. These are addends, this is a sum. Of course, when you add 0 to anything, it's the real number itself. We went over that before, so I'm going to skip it. Subtraction. Subtraction has some fancy words for the components of subtraction problem. There's these numbers. The first one, the big one, the thing you're subtracting from is called the minuend. The one that is behind, the one that you're taking away a certain number, that's called the subtrahend. You need to know these. Minuend is the first one. Subtrahend is the thing you're subtracting. The answer is called a difference. All right, you got it. You got it. You got it, right? Come on, don't be like April. All right, multiplication. What do we need to know here? This is easy. There's two main vocabulary words. You've got a factor and you've got a product. So the factors are the things that you're multiplying together. So these are all factors, and you can write it differently, of course. The product is the answer that you get when you multiply. So this is a product, and so is this. All right, if you multiply something by 1, you get the number that you started with. Okay. So you've gone insane. That's fun. All right, don't worry. We're getting there. We're getting to a really fun part, another really fun part, almost as fun as canceling. Of course, when you multiply anything by 0, you get 0. And even though it seems obvious when you do 4 times 0 is 0 and 15 times 0 is 0, you're going to get some really complicated math problems in the future. But if it has a 0 in there and they're all, like, even if it's surrounded by like pi, 3, x, whatever, if there's a 0, the whole thing becomes 0. And so you're going to love this property when we start getting to more advanced math, so trust me. All right, let's look at division. There are a couple vocabulary words. So if one number is divided by another number, the first number is called the dividend. That's what you start with, the big number that you start with. Remember, the dividend goes here. I'll just write end. And then the thing that you are dividing by is called the divisor. Right? I want to make sure that that is right. Yeah, the second number is called the divisor. So that and that is called the divisor. Divisor goes here. Okay, and then the answer is called the quotient. Okay, I'm going to assume that you know that. Let's go over review of operations with decimal numbers. Okay, you have to know this, and this is super important. When you are adding or subtracting any numbers with decimals in it, you have to line up the decimals before you add or subtract, and then you just go column by column, okay? So for example, this number, if you're saying that you have 1.005, you want to add 300 to it, you line it up exactly like I have here, and then you just start with the most right hand, and you do 5 plus 2 is 7, 0 plus 1 is going to be 1, 0 and 0 is going to be 0. Bring down that decimal. And then the next one is 1 in the ones place. In the tens place, you have just a 0. And in the hundreds place, you have just a 3. So this is going to be the answer there. All right, let's do example 4.1. What if we add these numbers? So this is super easy. All you're going to do, we just learned it, is line up the decimals. Let me get a nice bright color so you can see it. And then we start way over here. Now there's no number above it. So if there's no number above it, you're just going to assume that the number is 0. So 0 plus 3 is going to be 3. 6 and 6 is going to be 12. Carry the 1. All these ones together are going to add up to 3. 2 and 0 is going to be 2. 0 and 0 is going to be 0. Then you're going to bring down that decimal, and then you're going to do 4 and 0, which is equal to 4. So you've got a long, complicated number, but if you line everything up correctly, you'll get the right answer every single time. Let's do example 4.2. This time we're going to subtract. So it's easy because you do the same thing as addition. Oh, also note how they said the problem. Subtract this from this. So this is the number you start with, and this is what you subtract. Subtract this one. So don't get confused if they, the number that they gave, the order in which they give you the numbers is not necessarily the order in which the subtraction problem goes. You have to really pay attention to the subtraction problem, if that makes sense. Okay, now I'm going to make sure that I lined this up correctly. So from the decimal here, this is the tenths place, hundredths with the th. I don't have a lisp right now, just the th on the hundredths, thousandths, right? And then the 6 and 6 go together, and the 3 is lined up with nothing. So I'm going to add a 0 there because it doesn't matter if you add a 0 there, right? And we're going to subtract. This is a subtraction problem. So we're going to start here. 0 minus 3, you can't do that. We have to borrow. Let's make this a 5. And now this is a 10. So 10 minus 3, I'm going to put 7 down here. 5 minus 6. My goodness, I can't do that either. I have to borrow again. Let's borrow from this 1 and make that a 0 and make that a 15. So now 15 minus 6 is going to be 9. Oh my goodness, they're making us borrow all the way. So 0 minus 1, you can't do that. And we can't borrow from here or here, so we have to go all the way to here and borrow. Let's make this a 3, which brings the 1 there. But we're going to have to borrow from that, make it a 9, put the 1 here, which makes that a 10, but we have to make that a 9. And finally, we put the 1 there. My goodness, that was difficult. That's going to be a hard one for you because sometimes the borrowing gets confusing, right? So just do what I did right there and just practice it. We'll practice it and we'll get it right. So 10 now minus 1 is going to be 9. And now we should not have to borrow again because we did all our maximum amount of borrowing. So 9 minus 2 is going to be 7. 9 minus 0 is going to be 9. We bring that decimal down. And we have 3 minus 0, which is 3. And if I did this correctly, I should get the same answer as the book. And it looks like I did. So bam, easy, we got it. Example 4.3, we're going to multiply these numbers together. Now, the cool thing about multiplying and dividing decimals is that you do not have to line up the decimals. You do not. All right, so we're just going to multiply these numbers. Now, in order of operations, it doesn't matter which number you put on top or which number you put on bottom when you multiply. So I like to put the shorter number on the bottom, meaning like this is a 1 and a 6, and this has like a 406. It has 3 things that you're going to have to multiply. So it's going to be easier to put the more simple number on the bottom. So it's kind of like I'm just multiplying it by 16. All right, let's do 6 times 6 is 36. Put the 3 up here. 6 times 0 is 0, and then plus 3 is going to be a 3. Okay, now we do 6 times 4, which is 24. Okay, now we have to go through and multiply everything by the 1. I'm just going to erase that so it doesn't get confusing, okay? So, let's see. Let me get a different color too. So 1 times 6, okay, when we're doing the tens place, we put a 0 there. 1 times 6 is 6. 1 times 0 is 0. 1 times 4 is 4. Okay. And then what we do is we add. I didn't do a great job of lining it up perfectly, but 6 plus 0 is 6. The next row, 3 plus 6 is 9. The next row, 4 plus 0 is 4. Oops. And the next row, 2 plus 4 is 6. And then this is the answer we get. Now, what do we do with the decimals? We have to count how far over we need to put the decimal. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And there's no other place to put it, so I have to add a 0. And just by convention, whenever you have a decimal point, you tend to put a 0 to the left of the decimal. So this is the final answer. And that's the same answer as the book. That was a really hard problem, Addie, so don't be discouraged if you didn't understand it right away. Feel free to watch that again if you need to. Let's do example 4.4. This time we're doing division with decimals. Okay, so division with decimals. Whew. All right, let's do this. Divide 6.0 blah, blah, blah by 0.03. All right, so this is the number that we're going to divide, so that is the dividend. So I'm going to put that here. The second one is what we're dividing by. That's the divisor. So don't get those two confused. It's easy to get them confused, but don't let them trick you on that. I mean, there's plenty other stuff in math to get confused by, so don't let something like that confuse you. Now, here we go. So when you have a problem like this, we're going to change this number. We're just going to move the decimal over to make it a more simple problem. So I'm going to go 1, 2, and then whatever I do here, I have to do it to the dividend. So 1, 2. So let's move that decimal over 2 places. So if I do this, the decimal is now here. If I do this, the decimal is now here. Okay, so this is the same as this problem. Bam. Get it? Cool. So how many times does 3 go into 6? It goes in twice. 3 times 2 is 6. Subtract, bring down the 0. How many times does 3 go into 0? 0 times. 3 times 0 is 0. Subtract 0. Bring down that 3. How many times does 3 go into 3? 1 time. 3 times 1 is 3. Subtract, I get 0. Bring down that 9. How many times does 3 go into 9? 3 times. Then what do we do with the decimal? So this is the number I got, but what do we do with the decimal? You take it where it was in the dividend and bring it straight up into the quotient. And if you lined everything up correctly, this is there's something to be said here for good handwriting and good organization. Then your answer is 201.3. Yay! Okay, last topic, I promise. Last topic is unit multipliers. This is a great review. Okay, the thing to remember here that is this. If you multiply a number by a fraction that has a value of 1, you don't change the value of the original number. For example, let's say you have 5 over 1, and if you multiply 5 over 1 by 7 over 7, that's the same thing as multiplying by 1, like a big fat number 1. So it doesn't even matter. You don't change the number of 5 over 1. You don't change the value of that. So you get 35 over 7, but that's the same as 5. It's the same as what you started with. So it's kind of like saying if you multiply by 1, you end up with the same value of whatever you start out with. Easy peasy, but why would we ever want to do that? Multiply by 7 over 7? Well, we do it when we have unit conversions. So for example, you might want to change units from feet to yards, or vice versa. You might want to change it from yards into feet. So 3 feet is 3 feet in a yard. There are 3 feet in a yard. So that means this numerator is exactly the same length as this denominator. So this is kind of like multiplying something by the number 1, the big fat number 1. So if you multiply it by this, you can change the units of it and not change the value of the original number. So let's see how that works. This is actually super fun. I like doing this, and my method is a little bit different from what they describe in the book because I always make like this grid pattern like this, and I'll show you why. So we use unit multipliers to convert 32 feet into inches. So how do we do that? The important thing to know is that there's 12 inches in a foot. If you know that, then you can do that problem. So we start out with 32 feet. I put that on the top of my grid system. I know that I want feet to cancel out so that I end up with inches on top. So if I want it to cancel out, I have to put feet on the bottom. So that means I'm going to put 1 foot, and I'll just shorten it, is the same as 12 inches. And this is kind of like multiplying this whole thing by 1 over 1. Why? Because this value is the same as this value, so it's the same. So then once I have my grid system in place, then I can do my favorite thing in the world, which is canceling. Oh my heck, I love canceling. So let's cross out feet, because it's the same as on the top and the bottom. Now, the only thing I need to do is multiply everything on top straight across. What is 32 times 12? I don't know. I can't do that in my head. I'm just going to put 32 times 12. And then the units are the only units I have left, which are inches. And I have to move this over because I don't have room to write inches. There you go. So the answer is 32 times 12 inches. All right, let's do another example just to make sure that you've got this. Let's say you're starting out with 36 feet. If you're following along, this is on page 20, and it's example 4.6. And we want to change this into miles. And they're going to give us a hint because they're going to tell us this important fact, which is that there's 5,280 feet in 1 mile. That's going to be your 1 over 1 equation, right? Your unit conversion. So if we want to change feet to miles, this is what we do. We set up our little grid system. I have 36 feet on the top because that's what I'm starting out with. I want to put feet on the bottom so that they cancel out. So I'm going to put feet on the bottom, and I know that there's 5,280. I made it kind of run into, okay, I'm going to do 5,280 feet in 1 mile. Okay, so there's my grid system. What can I cancel? It's my favorite thing to do. I can cancel out feet, and I can cancel out feet. The units are the things that are canceling out here. So now with my grid system, anything that is on the top, you multiply. So 36 times 1 is just 36. Anything that is on the bottom, you divide. So divide that by 5,280. Whatever you get for that answer, then that is the answer, and it turns out to be 0.0068 of a mile. Okay, and the unit is miles because that's the only unit left. Let's do another one. I'm so excited about doing another one. I feel like her. You're probably not as excited. Okay, they want us to take the number 47.25 inches and turn it into centimeters. And they also give us a hint here that 1 inch is the same as 2.54 centimeters. All right, so what am I going to do? I am going to take my 47 inches and I'm going to start out with that. And I'm going to shorten inches because it doesn't fit on my little grid system. There we go. So we're starting out with that. Now, I want inches on the bottom because I want it to cancel out. I'm thinking ahead. So I've got 1 inch is the same as 2.54 centimeters. Okay, got my grid system. What can I cancel? I can cancel inches. And so since both of these numbers are on top, I'm just going to multiply them straight across. 47 times 2.5 about. And you get, well, it doesn't, it's funny because it doesn't give you the final answer in there. It just says 47.25 times 2.54. The important thing is that the units is centimeters because that's the only unit I have left. The inch is canceled. So that's how many centimeters you would get. It would be something around double, 2.5 times that much. All right, let's do another example because we are having so much fun. Yay. So they want us to turn 42 meters into how many centimeters? Whoa, I already know that this is going to be a lot of centimeters because there are 100 centimeters in a meter. They don't give us that hint. They just kind of expect us to know that. So I'm going to take 42 meters. How about I take just that, put it there on my little grid system. Okay. And then I know, just because I know that I want to have meters here and I want to turn it into centimeters. So there are 100 centimeters in 1 meter. Okay, so how do I know that? I only know that because of the prefix centa, like a centipede, which has 100 feet. Well, supposedly, 100 centimeters in a meter. You should know that just because it's the metric system. So here we go. Meters cancel out. Yay, that was so satisfying and fun. And on the top, we multiply these numbers straight across. 42 times 100 is 4,200. And the answer is in centimeters because that's the only unit I have left. Easy peasy. You know what's twice as fun as that? Is using 2 unit conversions together in one problem. So they want us to do 2 unit conversions in order to turn 42 feet into how many centimeters? Okay, this one's going to be so fun, but you have to pay a lot of attention to this one. So we're going to start out with 42 feet. I'm going to shorten it. 42, and I'm just going to abbreviate feet. The first thing I have to do is convert feet to inches. So I'm going to put feet on the bottom so that they cancel. I know that 1 foot has 12 inches in it. So again, this is like multiplying by 1, but the feet are going to cancel out eventually. All right, now I know I'm going to be left with inches, but they don't want inches. They want centimeters. So what do we know about those unit conversions? Well, they told us in the previous problem that there are 2.54 centimeters in an inch. Now, which goes on the top or bottom? Centimeters or 1 inch? The way that you can mess this up is you don't know whether this goes on the top or bottom or whether this goes on the top or bottom. But all you have to do is think ahead and get them to cancel. And they only cancel if one is on the top and one is on the bottom. So let's start canceling. Okay, this foot cancels this foot. This inches cancels this inches. And I'm going to be left with units of centimeters. And so all I have to do is multiply everything that's on top and divide by anything that's on bottom. Now, these are all ones on the bottom, so we don't really have to divide by anything, but you might have to in some other problems. So 42 times 12 times 2.54. They don't give us a number, but they just basically say that the answer is the multiplication of all of those together. 42 times 12 times 2.54. And the answer is going to be in centimeters. Bam, that's all you have to do. All right, last problem, last example. Now you're saying yay. You're saying yay because it's the last one. I'm saying yay because I'm having so much fun. All right, let's start with 4 miles. They want us to get to inches. Whoa, that's going to be a buttload of inches that are in 4 miles, right? This is going to be a humongo number. All right, so how do we do this? We're going to have to do a couple unit conversions. I know that I'm going to want to cancel out this miles. So I also know that 1 mile, we know this from one of the other problems, has 50 to 80 feet. Okay, but I'm not to inches. They want inches. So let's get feet to cancel out. So in 1 foot, there's 12 inches. Now I know that the feet are going to cancel out, and we're going to be left with inches. So let's cross out miles, that cancels. Let's cross out feet, that cancels. So all we're going to do is 4 times 5,280 times 12. That's the answer, and the answer is in inches. And they don't make you go through and multiply that. They just do that multiplication. They just show that as the problem. All right, so you are going to have a table in your book that looks like this. You can use this when you're doing your homework. These are equivalent. So 3 feet is equal to 1 yard. That means that you could put 3 feet on the top, you could put 1 yard on the bottom, or you could switch it and put 1 yard on the top and 3 feet on the bottom. Either way, that ratio is going to be 1 over 1. So they want you to use this table when you're doing your homework, but not a calculator. No calculator. All right, guess what? You are finally done. Love you, Addie. Have a great time doing your homework. Bye.